Hello everyone. So today I am here to describe about our multilingual AI assistant designed specifically for Indic languages. The core motivation behind this research is the lack of robust conversational AI for diverse Indian languages. While large language models like ChatGPT, Gemini, and Mistral perform well in English, they struggle when it comes to multilingual understanding and generation, especially for low resource Indic languages. So we built Saarthi, a pipeline that translates the input in an Indic language to English using AI for Bharat's state of the art translation models, passes the translated text to an English LLM for processing, and then translates the response back into the original Indic language. This bridges the gap between Indic language users and the power of large scale LLMs. So, here are the Indic languages. It covers almost 22 Indian languages, and we have evaluated our model using Blue Score, Rock Score, and Meteor Score. And our model outperformed ChatGPT, Mistral, and Gemini in multilingual response quality. So here is the architecture. First, the user will enter the query in any language. Then the query will pass through the AI for Bharat Indic Trans model, which will convert based on the user language to English text. And this English text will pass through an LLM like ChatGPT, Mistral, or Gemini. And this response that the LLM generates will be in English, and the response will again pass to the AI for Bharat model, which will convert it into the original language of the user that user entered while uh, giving it query. So the final response will be in the original detected language. Thank you.
So I will be telling you how this dataset was collected. So our dataset was collected for basically 8 distinct Indic languages, that is Hindi, Tamil, Telugu, Bengali, Marathi, Gujarati, Kannada, and Malayalam. So the content was sourced from diverse range of platforms to ensure linguistic richness and topical variety. These were from reputed online educational websites or from the regional or national media news outlets. So then we curated the set of topics, which was uniformly provided to ChatGPT, Gemini, and Mistral, and our model Saarthi, which generated the content for the purpose of evaluating and comparing the quality and performance of each model. So our this is how our data set looks like. We have reference answer which was given by ChatGPT, then by Gemini, then Mistral, and then by our model Saarthi. So how did we evaluate our models? First one was the Rogue score. So what is Rogue? Rogue is oriented understudy for gesting evaluation. This is done by calculating similarity scores between words or sentences. This there are three variants: Rogue Score 1, Rogue Score 2, and Rogue Score L. Rogue Score 1 is for unigram overlap, that is word to word. Rogue Score 2 is for bigram, and Rogue Score L is longest common subsequence, that is longest sentence uh, that is found between the two. Then interpretation. Higher rogue score means more overlap with reference. That means better coverage of important information, which is commonly used for summarization of NLG evaluation. Let's see rogue score comparison. So overall rogue score for our model was highest among the all three top class models, as you can see in the data here. Then for language wise, you can see for Gujarati, Saarthi has scored 0.3, which is top among all other models. Similarly, for Rogue Score 2 and Rogue Score L, Saarthi has scored the best. Also, you can see for all the other models, Saarthi has scored the best. Now, my friend will explain the blue score. Thank you.
So here we are calculating blue score. What does blue stands for? Bilingual evaluation under study. What do we measure from it? How closely machine generated text matches reference translation, which was collected in our dataset through various websites. How it works? Compares overlapping n-gram between generated and reference text. The higher blue score means better translation precision. We have calculated 4 gram in this 1 gram, 2 gram, 3 gram, and 4 gram. Our Saarthi achieves highest scores across all blue levels in all the 8 indic dataset which we have collected. If we see the score for blue one, it's 0.1199, which is highest we can see among all the other models. Similarly for blue 2, blue 3, and blue 4 as well. And if we see by language wise our blue score, we can see the blue 1, blue 2, blue 3, and blue 4. If we see for the Gujarati, let's say this one, blue 1, it is 0.440, which is greater than 0.391, and 0.408, which is by Gemini, and 0.422, which is by ChatGPT. Similarly, we can see for the Bluetooth score as well, which is 0.310, 0.295 by Gemini, 0.282 by Mistral, and 0.328, which is by Saarthi model, which is our model, which is highest. Similarly, we can see for a Blue 3 and Blue 4 as well. Now, if we look for the Meteor score, why do we need Meteor score? Designed to overcome Blue's weakness by including semantic similarity. What is the feature of it? Consider synonyms, stemming, and word order. Balances precision, recall, and semantic alignment. More meaning preserving and fluent outputs for higher Meteor score. If we see the overall Meteor score by Saarthi model performs 0.106, which is highest among all ChatGPT, Gemini, Mistral. And if we see language-wise Meteor score for Gujarati, let's say ChatGPT says 0.1232 score, 0.1138 by Gemini, 0.1073 by Mistral, and 0.1339 by Saarthi. So, among all three scores which we have calculated, ROG, Blue, Meteor, overall, if we see for the Indic languages, we make a conclusion here that it performs better than the other models. Now, I would like to invite Prince to walk through the code in front of you.
So hi everyone, I will walk you through the entire project code base which we have built, worked together this whole semester. So basically we have built a Flask application which will act as a server which will render our entire Saarthi project. So the first main application is that this app.py file where we have created two endpoints, that is the home route which will serve the index dot the main home page, and there is a process API which we have created using the REST APIs, where we see if we when the user calls this API from the UI, this function gets called. The from the request the query is getting extracted, that is user text, and that user text is passed to this function where everything processing will happen. When this function is called, then when the user text is provided, then we first translate it into English. What happens in this function is it first detects the language of the user input given by the user, and then it gets translate it into English. After translation, the text, the query is passed to the Gemini model or any kind of LLM model which we have used here, and the response is generated in English only. After the response generation, as we can see here, the model translates those English response back into the original detected language which we have passed here. After the response generated and got translated into the original language, it is getting served via the API on the user interface. This is how the entire Flask application is working in the backend. Talking about the front end side, we have created this JS script and the style.css file where every UI based logic is happening. This is the index.html file where we have made the which we have used to make the UI. After this, we have deployed this entire application on cloud AWS, where I can show you this is the Saarthi instance name Saarthi server which we have created using EC2 instance. If we look at the details of this EC2 instance, we have created a virtual machine on the Amazon AWS using the hypervisor, and this is the public IP4 address where we can access this URL. Access this URL which will serve our entire project on the internet, and anybody can access this app using this URL. Here we can see this is the UI. This is how it looks. If I say hi, this is the response how it everything UI looks. This is the dark mode switches. So using this URL, anybody on the internet can access our page. So this is our whole project deployed on AWS. We can also access this machine using the terminal. See, this is from the terminal we can SSH into that remote virtual machine, and we can perform any kind of action using the cloud computing techniques. So after this, I would like to invite my friend Sandeep to take you forward from here.
Thank you, Prince. So as he has already walked through the code, so let me show you the demo, what the user sees at the front end. So let me give you an instance for it. So if I will search that what is cloud computing, so it will generate a kind of comprehensive answer for the question that has been asked by the user, and not in the one language, but in the different languages. So this is the detailed overview of what the cloud computing means and what it contains. If I will ask it in Hindi, for which I have already written, so it will generate the content related to different languages. Since we as a user understand Hindi and English only, so we are testing it on the Hindi and English also. So if you look at the Kannada, then it will also generate on Kannada. This all I'm just giving for instances and examples to have a clear understanding of it. So this is the Kannada version of it. That what is cloud? The same question has been in 3 different languages, and this is the output that it generates. So this is the functional output, or what you can say the user that will view through this Saarthi that we have made. So moving ahead, let's understand what is the social impact that this project and the product can lead to. First of all, it has been tested on 8 different Indian languages, but at present it supports 22 different Indic languages. So what it will lead to? It will lead to kind of artificial intelligence democratization among the Indian population, especially for the people and the students who live in the Indian villages. At the same time, it promotes the inclusivity. Inclusivity means that a student from village can also access the resource in its own vernacular languages, and they can go ahead with it. Third thing is it is significantly in spreading the AI impact on the Indian population. At the same time, it means a kind of it's a kind of social, and it's kind of technological for the social improvement. Future developments, we are thinking about including the voice based interactions, real time deployments, and including many different related means kind of technological advancements. At conclusion, I want to mention that this model is what I feel is completely ice breaking in the field of multilingual facilities which are currently in our nation. So at last, thank you very much for giving us this opportunity, and once again, thank you.